students. So here's a cool little application of multiplying polynomials together and what to do with the results. Here's an example where I have a box, I have some cardboard, and I want to maximize the volume. I start with the cardboard's 11 by 19 inches. And of course, I need to fold up the sides to make like a shoebox. And so I want these to all be the same, some value of x. And I want to change that x so that I can get the most volume possible in that box. Maybe I'm shipping something and it'd just be cheaper to do it this way. So I can start by figuring out what the volume is and then graphing that equation. I'm going to start by looking at, let's just use the black here to start with. I know that volume is length times width times height. That I know to be true. So when I look at this situation right here, I know that the height, when I fold up those sides, the height of the box is going to be x. Now I want the length of the length is from here to here. That's the L. And then the W, and I know this seems a little strange this way, the W is from there to there. So the length, and a lot of times my L, I try to make it a cursive, but then it looks like an E, but anyway. The length there would be the 19 minus 2 x's. So the length here and the length here is the same. It's 19 all the way across, and then you take away that x, and that will give you what you have left. That means that the width would be 11 minus those 2 x's. Once you have that set up, it's not hard to find the volume, because the volume is length, which is 19 minus 2x, times the width, which is 11 minus 2x, times x, your height. Now, I still like the box method for multiplying those. They're binomials, but they're also polynomials. But since there's only two terms, we call it a binomial. And I do a little math here, and I get this to be 209. And this would be minus 22x. And this would be minus 38x. And then plus 4x squared. So now I have, and we'll put it in standard form, 4x squared minus 60x plus 209 times x, and then I just distribute that out. And remember, you add the exponents, so it's 4x cubed minus 60x squared plus 209x. So this would be in factored form right here, and this would be in standard form. And then I'm going to go ahead and graph this real quickly. I think I did it on my Desmos calculator here. And you can graph it either way. I went ahead and multiplied it out. I noticed that, oh, well, after the height is 9.5 inches, it goes on forever and ever. But the problem is you can't have the height more than that, because then you'll be missing one of your sides. Well, the sides would be so small. Yeah, they wouldn't exist. So actually right here is where that you'd lose 5.5, you would lose your width. You would lose it, because 5.5 would give us 11 if we had two of those, and then we wouldn't have any width to our box. So anyway, back to this. What is it saying? This is my x. That's my actual height of the box. And the y value is the volume. So if I look up here and it says 2.246 for x and 212.1, let's say, for y, I see that if I'm going to hit on that, yeah. So if my height, my x, is, say, 2.25. You might have to make it just round it to the nearest whatever. Sometimes they truncate it, sometimes they round it. Let's say rounded to the nearest hundredth, 2.25. Then I would get my maximum volume of 212.06 approximately. That's kind of handy to know if you were designing a box to have the maximum volume given that the dimensions there. So you would have to cut out squares that were 2.25 on each side. If I go back to my Jamboard. So when x is 2.25, I get my maximum volume. And what did we say it was again? It was 212.06. All right. So that's some good information, a real practical application. I know the videos talked about money and investments, and this is just a different application. So hope this helps when you're trying to work through some of these problems.